This is our car crash investigation by Jackson Britt, Connor Robertson, Cole Masson, and Connor Grimes. So the introduction to our car crash investigation is when a traffic accident occurred in a 35-kilometer-an-hour speed limit zone in which a 3,000-kilogram Cadillac Escalade SUV rear-ended a 2,000-kilogram Subaru Outback wagon at a stopped red light. Because we know the SUV came to a stop after the collision, we can say that the final velocity is 0, and as it states on our initial investigation paper, it has an acceleration of -2, which replaces A, and then it traveled a distance of 2 meters, which replaces the distance. By solving this equation, we ended up getting an initial velocity of 2.82 meters per second. We did a similar process for the wagon's velocity, in which we plugged in the exact same numbers, except the distance was 24 as stated in the investigation, and the acceleration was -3 instead of -2. This ended up giving us an initial velocity of 12 meters per second.
For the velocity of the wagon before the collision, since it's at rest, you know that the velocity is 0 meters per second. In finding the velocities before the collision for the SUV, you need to use momentum. And momentum is mass times velocity. And the only velocity in the whole momentum equation you don't have is the SUV before the collision. So you get 3,000, which is the mass, x equals the rest of, since that equals 0, since at rest, and 2,000 times 0 equals 0. So equals, after all that, you solve for x and you get that.
The type of collision was inelastic because the difference in kinetic energy was greater than 10%, or more specifically, 12.74%. The speed limit was broken as the SUV was speeding about 4 kilometers per hour over the speed limit.
For the energy of the SUV before and after the collision, the SUV lost around 2 million joules of energy. For the Outback wagon, before the collision, it had 0 joules, and during the collision, it gained 1.8 million joules. For the energy of the whole system, before the collision, it had 2.2 million joules of energy, and it lost 250,000 joules.
These are the impulse graphs, which is force over time. And as you can see, as the SUV goes down, the wagon goes up. And as the wagon goes down, the SUV goes up. For the impulse graph of the system, since they cancel each other out, the force over time always equals 0.